welcome to this video tutorial on how to name carboxylic acids using IUPAC nomenclature. I'm going to show you how to name some basic acids, then we will build up to more complex structures. Carboxylic acids are part of the family of functional groups that are based on the carbonyl group as the starting point. The carbonyl has one of its two groups attached as the hydroxyl group. Unlike alcohols, the use of the carbonyl group allows the hydroxyl group hydrogen to have a higher degree of acidity to it. Electron density is inductively pulled away from the less electronegative hydrogen. As with any organic compound, the first item to consider is where this new functional group resides in terms of priority compared to the other functional groups we have encountered. Here's the latest priority list for organic functional groups. Alkanes and their related groups, like alkyls, halogens, aromatics, and cycloalkyls, still have the same low level of priority. Due to the carbonyl carbon being attached to not only one, but two oxygen atoms that have higher atomic mass, the carboxylic acid group is higher in priority than any other functional group, higher than alcohols, ketones, or even aldehydes. We will begin by looking at this first molecule and name it. So in examining our molecule, we need to find the longest continuous carbon chain that includes the highest priority group. For this structure, this is the carboxylic acid. This is higher in priority than the alkyl group or the alcohol OH group. In numbering the longest chain, we make sure to give the carboxylic acid group the lowest possible carbon number. This would be a 4-long carbon structure. This carbon link could go in two possible directions. One follows along a path that just leads to alkyl groups, while the other path leads to the next highest priority group, the hydroxyl, being placed directly under the parent chain. The preference is to use the path that actually involves the hydroxyl group, plus the hydroxyl group also comes alphabetically. Now we'll take a look at our substituents. We have a isopropyl group hanging off of carbon 2 and a hydroxyl OH alcohol coming off of carbon 3. This will be a 4-carbon long chain. For an alkane, would be butane. To change the name to show that the molecule is an acid, I would drop the E in the ane suffix and replace it with oic acid. So the parent name of this compound would be butanoic acid. Next, I place the name of the substituents in front alphabetically. First alphabetically is 3-hydroxy for the OH group, followed by isopropyl at the 2-carbon position, and then we follow that with the name of our parent, butanoic acid. So the full name of this compound is 3-hydroxy 2-isopropyl butanoic acid. Let's take a look at a slightly different molecule. And looking at our molecule here, we need to find the longest continuous carbon chain that includes the highest priority group. In this structure, our functional groups are an aldehyde and a carboxylic acid. The highest priority group is the acid. The longest chain ends up being 6 carbons long, highlighted here in yellow. So here's my numbering: 1, 2, 3, 4, 5, and 6. I'll identify my substituents next, highlight those in a different color. I've got 2 methyl groups on positions 4 and 5, a aldehyde on carbon 3, and those are the only substituents I have. So in naming this compound, a 6-carbon long chain for an alkane would be hexane, but since this is a carboxylic acid, we drop the E and replace it with oic acid as the suffix. So this is hexanoic acid. No need to add the location of the group since it is implied to be on carbon number 1. So again, there are 3 substituents on this parent chain, an aldehyde group on carbon 3, and 2 methyl groups located on carbons 4 and 5. When an aldehyde group is a substituent rather than part of the parent chain, the name of this group is called formal. We designate the location of the formal group just as we would for any other substituent located off the parent chain. So the complete name of this compound is 3-formal 4,5-dimethyl hexanoic acid. Our last molecule that we'll be naming has the following structure. In taking a look at our molecule, we need to find the longest continuous carbon chain that includes the highest priority group. In this structure, our functional groups are a halogen, chlorine, and not 1, but 2 carboxylic acid groups. The highest priority group is actually both of the 2 acids. So we need to be sure we include both of these carboxylic acid groups in making our parent chain. The longest chain we can get with both carboxylic acids ends up being 4 carbons long, as I've highlighted here in yellow. This gives acid groups on carbons 1 and carbon 4. But we could number in 2 possible directions. Which way do we number? In looking at the substituents located off the parent chain, we have 2, a chlorine and a methyl group. We number so that we give the lowest number to the substituent that comes first alphabetically. Since chloro comes before methyl, chloro substituent gets carbon number 2. And I'll highlight my substituents next, the chlorine substituent and the methyl substituent. This is a 4 carbon long chain. For an alkane, this would be butane. But since this has 2 carboxylic acid groups, we actually do not drop any of the name of the alkane. Instead, we keep all of butane and then add di in front of the oic acid suffix. Dioic acid is used to designate 2 acids in the chain. So this is butane dioic acid. No need to add the location. It is implied that the acids can only be on carbons number 1 and number 4. In adding our substituents, we get the final name of this compound, 2-chloro, 3-methyl, butane dioic acid. Thanks for watching this video tutorial on naming acids using IUPAC nomenclature.